Hello friend, today's my topic is induction motor. So this is your induction motor. This is induction motor. Induction motor looks like this. Okay. So this is some these are some important points regarding induction motor. First point is what there's written an induction motor works on transforming action. What does it mean? What does it mean transforming X? So if we have to recall about the working, if we will recall the working principle of transformers. So what we are saying, transformer works on principle of mutual induction. And there's similarity between induction motor and transformer. Induction motor is also works on principle of, just like transformer, principle of mutual induction. So that's why it is all one interesting fact about induction motor. That's why it is also called rotating transformer. That's why it is also called rotating transformer. Yes, there is also some similarity and some differences. If we are comparing if we will compare induction motor to the transformer. What is similarity? The working principle of both the machine are same, and yes, there is in transformer there is two winding. In induction motor, there are two major parts: a stator and rotor. So a stator is behaves like primary winding, and rotor is behaves like secondary winding. But if you will recall the working principle of transformer. So what is the frequency of primary and secondary winding is same, but in case of induction motor, the rotor frequency is not same as a stator frequency. But there is a relation between rotor frequency and a stator frequency. So later it will be discussed in your later slides. So okay. And third was what there is written, it is also called asynchronous motor. So, in simplified manner, we can understand asynchronous means the speed of rotor is not synchronized with the speed of a stator magnetic flux. Okay, so that's why it is called asynchronous motor. So if we are talking about the construction like other rotating machine, what in previous semester we have studied DC machines. So there is two major parts. First one is a stator, second one is a rotor. So like other rotating machine, it has also two parts, a stator and rotor. A stator obviously it is a stationary part of the machine, and rotor it is the rotating part of the. But yes, if you compare DC motor with induction motor, and that means if we compare constructionally, then what is the major difference between them? If you recall the construction of DC motor, where the field winding is present, field winding present in the stator, and armature winding placed in the rotor. But in case of induction motor, the field winding is present in the rotor, and the armature winding is present in the stator. This is the major constructional difference between both the machine. Okay. Yes, a stator. You can observe this diagram for the construction of alternator. So there is a slotted structure, slot and teeth type of structure where your three-phase winding is placed. Okay. It will be better visualized. It will be better visualized from this diagram. So a slot and teeth type of structure, slotted structure is present there, and three-phase winding is wounded here. Okay, so you look how much simpler the construction of a stator. That's why, due to simplicity of the construction of induction motor, it is very popular. popular machines. So most of industrial load, 80 to 90% of the industrial load are the induction motors. Because the simplicity of construction and rough and tough behavior, that means maintenance-free construction, make it more usable. Okay, or we can say usability of this type of machine increases due to simpler construction or a rough and tough construction or maintenance free construction. Okay, so this is your starter. This is another picture of a starter. Yes, a starter has three main parts. First one is outer frame. It is outer body of the motor. It protects the inner part of the machine. Or we can say it provides support, a structure where machine can assemble. And second one is a starter core that is built upon high-grade silicon steel. Why it is made high-grade silicon steel? Because to reduce hysteresis losses. Silicon steel is a high permeable medium. So, if we are making a starter core of silicon steel, that means hysteresis losses will be less. This is very, very important question, generally asked in competitive exams. Okay. And your also placement drive and also your semester exam. And a starter binding. Yes, obviously, it has a three-phase binding. It has a three-phase binding. Rotor. If we are talking about the rotor, there are two types of rotor in a squirrel cage induction motor. First one is a squirrel cage rotor. Second one is phase wound, or it is also called slip ring rotor. So first we will see a squirrel cage rotor. This is your construction. This is construction of a squirrel cage rotor. Here two in rings are present here, and this is your two in rings and copper conductors. Copper and aluminum conductors. Coppers and aluminum conductors. Aluminum not conductors. Bar are short circuited in between two rings. Okay, and you can observe here these bars, these copper aluminum bars are not parallel to the shaft. It is slightly askew. What is the region of skewing of these bars? We will discuss in next slide. Okay. So this is your shaft and bearing. So these are the constructional feature of a squirrel cage rotor. Okay. Yes, these are some important points. It consists of a laminated cylindrical core. Yes, we will see in later diagram how the laminated core looks like, and semi-cloth circular slots on the outer periphery. And copper and aluminum bar conductors are placed in these slots and short-circuited at end by copper and aluminum ring called short-circuited ring. What we have seen in the previous diagram. Two rings are presented in between two rings, their coppers and aluminum bar are connected. And yes, third point is very, very important. The rotor binding is permanently short-circuited and there is no possibility of any external connection in such type of rotor. Okay, so we will show what is the disadvantage of this arrangement. We will discuss in when we will discuss about slip ring induction motor. Okay. So yes, what was we are discussing in previous slides? Or observing in previous slides, the rotor slots are not parallel to the shaft but askew. What are the advantages of such type of arrangement? First advantage, you reduce humming noise. What is humming noise? When you absorb when motor is running, there is noise coming. That is called humming noise. And second advantage, provide a smoother torque for different position of the rotor. And third, this prevents magnetic interlocking between a stator and rotor. Okay, so these are the advantage of the skewed slot, and this is important questions for examination, for your examination point of view. Generally asked, what are the advantage of skewed slots? Okay, this is another pictorial representation of a spiral cage motor. Okay. Yes, you can better visualize the construction of a spiral cage rotor from this diagram, how it is constructed. Okay. Yes, when you will dismantle the machine in your laboratory, you will find similar construction like this. Okay. This is your actual visualization of your spiral cage rotor. Okay. Phase wound rotor. Or it is also called slip ring rotor. So, what is the major things, major features of phase wound rotor? Is in such type of rotor, or in this type of rotor, your rotor binding is similar to the stator binding, or it has also same number of poles, or your rotor binding has the same number of poles as a stator binding. And another one important thing is there is a possibility of external connections, external rheostat connections. This is not possible in your spiral cage induction motor. So, due to possibility of external connection or external rheostat connection, the torque or a starting torque, particularly a starting torque of this type of induction motor, is better than your spiral cage induction motor. So yes, this is the one of the disadvantage of the spiral cage induction motor. Their starting torque is not so much good compared to a spiral cage induction motors. A starting torque of slip ring induction motor is good because of the possibility of external resistance connection. What happens when we are adding resistance in the rotor circuit? Rotor draws more current. If it will draw more current, that means torque will be greater because your torque is proportional to current, directly proportional to current. Okay. Or current IS. Torque is directly proportional to IS. Okay. Okay. These are some important points regarding slip ring rotor. Okay. So it consists laminated core having semi-closed slots, outer periphery, and carries a three-phase insulated binding, what we have observed in previous slides. And rotor is wound for the same number of poles. We have already discussed in previous slide also, same number of poles as the stator, and three-phase terminals are connected together, forming a star terminals, and that is connected to slip rings fixed on the shaft. Okay. Fixed on the shaft. Yes, this is your spiral cage induction motor. Yes, if anyone will ask you how you identify without dismantling the machine which one is a spiral cage, which one has a spiral cage rotor, and which one has slip ring rotor, then you can easily see the machine which have larger axial length, that is slip ring induction motor, and which has a smaller axial length, that is your a spiral cage induction motor, because due to slip rings and external stat connections, the size axial length of the machine increases. Okay, so principle of operation, how it works. This is very important. What happens when we are giving three-phase supply? Where we are giving three-phase supply in a starter three-phase induction motor, then there is a rotating magnetic field develops around a stator periphery of the motor. A stator periphery of the motor. When that rotating magnetic field links with rotor conductor, as per the Faraday law of electromagnetic induction, there is EMF induced in the rotor conductor, and as per the result of EMF, there is current flows in short-circuited conductor, and we have seen the conductors are short-circuited, and as per electromechanical principle, when current carrying conductor placed in a magnetic field, it experiences a torque. Due to that torque, rotor starts to rotate and it's trying to catch up synchronous speeds. What is synchronous speed? Basically, synchronous speed, the speed at which the rotating a stator magnetic flux revolves around a stator periphery. So, rotor tried to catch up synchronous speed, but it is unable to catch up synchronous speed. And this difference of a speed is known as slip. This difference of a speed is known as slip. So what is slip? It is basically nothing else. It is difference of your synchronous speed and actual speed of the rotor. When it is represented in terms of percentage, then percentage of slip can be written as ns minus n divided by ns into 100, where ns is your synchronous speed and n is actual speed of the rotor. So this is slip, and next, so this is all about construction and working principle of induction motor. So in next classes we will study torque slip characteristics and other things which we have not studied in other classes. Okay, thank you all.